everyone, and welcome to my kitchen, which is where I will be doing a lot of my little video broadcasts from, trying to show you some stuff and keep the course moving along as best we can. So, what were we talking about last, and what did you have homework on last night? One of the things that you had homework on was the concept of liquid pressure. So just want to remind you what that's all about. And this is what we were talking about in class on Friday with scuba diving and Jordan's experience for telling us about different levels of certification and what the dangers were associated. But just to remind you from the reading, we have our little column of liquid here, and the further you go down, the greater the pressure on you. And the reason was because of the weight of the liquid on top of you. And we figured out that that pressure was determined by a couple of factors. First was the density of the liquid. Here, just normal water. The second thing was how far down you are, or the depth, because that's going to determine the size of the water column that's on top of you. And that last factor was just g, little g, because gravity is involved in this. We'll look a little bit more at some those equations again. But just wanted to remind you about that fact of liquid pressure because it's going to play a real huge role in what I want to talk about today, which is the concept of buoyancy. So if I said to you the word buoyancy, hopefully the next word that would come to mind is the concept of floating, right? Because that's what buoyancy tends to be about, right? So if I take this little thing, which is, I don't know, a weird maraca-like instrument I got, and I put it in, you will see that that floats, right? That there's got to be some force holding up that egg, right? Because gravity is pulling it down, and something has got to be supporting it. And that force is called the buoyant force. And that's really what we're going to be talking about, is the buoyant force. And the buoyant force is going to help us figure out whether things sink or float, right? So obviously this thing floats. I take this little super bouncy ball, and that floats as well. Take my coin, that doesn't float, right? So we're going to try and figure out, so what happens for something to float and something to not float? So at the end of the day, very simple. An object will float if the gravity force downwards is smaller or equal to the forces upwards, right? So if what's pulling it downwards is greater than what's trying to push it upwards, then an object is not going to float. An object that's floating, those forces have to be in balance with one another, right? Because if the upwards force was bigger, it would shoot upwards. If the downwards force is bigger, it would shoot downwards. And if they're balanced, it would stay where it is. So that's our floating condition, that the gravity force doesn't overwhelm the buoyant force. So, a couple of things about this. The first, I've got a little chunk of rock here. It's a chunk of obsidian I got from Iceland. Fits in my container. And if I put it in there, I think you'll guess that, oh my God, there we go, is not going to float. Right? That just clanged to the bottom. But I think a misconception that people have about the concept of floating and the buoyant force is that this rock, because it sank, isn't experiencing a buoyant force. And that's not correct. Everything that's submerged in a fluid experiences a buoyant force. So pardon me for a second, because I want to just take this rock out and I don't want to make a mess. There we go. I just spilled out some of the water, and there we have it. So, we're going to talk about a couple of things about the buoyant force, but a couple of things to notice first. Notice here the level of the water, right? And notice then, when I put the rock in, that level of the water went up. Well, why did it go up? Well, that's super easy because the rock takes up volume. And so the rock displaced a volume of liquid and pushed it upwards, right? That's going to be super important because since the liquid was pushed upwards, there's going to be an effect on the rock because of that, or at least on anything. Anytime you put an object into a fluid, it's got to displace the fluid. And the amount of fluid displaced, specifically the weight of the fluid displaced, is going to be equal to the buoyant force. And that's going to be something that's called Archimedes' principle. Right? And so we see that here, that this weight of the fluid was displaced, and therefore this rock is experiencing a buoyant force. That happens to a lesser degree with this. If I put the egg in, the fluid rose a little bit, but not much, because if you notice, I didn't displace a lot of volume because the the egg isn't entirely submerged. So let me do something else here. Boom. If I push the egg under the water, it pops up, right? And it pops up to a certain point such that part of the egg is submerged and part of it's not. And that's going to be related to the buoyant force. So I'm going to stop this video here, and then we're going to go and I'm going to write you some notes so that you can see some of this in action, but I just wanted to show you this in action for now.